Today we will learn the chemical cleaning procedure of reverse osmosis or RO plant membranes. Due to the continuous flow of high concentrated salt water, scaling of salts are formed on the surface of membranes. These scaling increase the inlet pressure and differential pressure across the membranes. There are two types of chemical cleaning procedures. 1. High pH or alkaline cleaning. 2. Low pH or acidic cleaning. When to clean. For best efficiency of cleaning procedure, elements must be cleaned before fouling has fully developed. If cleaning is postponed for too long, it will be difficult or impossible to completely remove foulants from the membrane surface and re-establish full performance. So, it's very necessary to remove these scaling from the membrane surface for smooth reliable plant operation. The procedure which is performed to clean these scaling is called chemical cleaning procedure. Chemical cleaning procedure, sometimes also known as CIP or clean in place, because in this procedure we do not remove the membranes from their place and perform the cleaning on the same place. There are two types of chemical cleaning procedures. 1. High pH or alkaline cleaning. 2. Low pH or acidic cleaning. It is more important to know that which type of cleaning procedure is suitable for your membranes or plant. To know this, first of all we should analyze that the membrane scaling is high pH or low pH. If the scaling pH is low, then we should perform high pH or alkaline cleaning procedure. If the scaling pH is high, then we should perform low pH or acidic cleaning procedure. High pH chemical cleaning procedure. Required quantity of CIP solution. 40 to 80 liters for each 8 inches element, depending on the severity of the fouling, and 10 to 20 liters for each 4 inches element, depending on the severity of the fouling. CIP flow rate. Recommended flow rate. 100 to 150 liters per minute or 6 to 9 cubic meters per hour for 8-inch vessel, and 25 to 36 liters per minute or 1.5 to 2.2 cubic meters per hour for 4-inch vessel. The goal is to try and achieve the recommended cleaning flow rates above, while keeping the cleaning solution pressure within the CIP pressure range of 15 to 30 psi. CIP pressure. Low pressure from 15 to 30 psi. Required chemicals. 1% EDTA by weight plus 0.1% NaOH, pH of the solution should be 12 and temperature range is 35 degrees Celsius maximum. Steps of cleaning. Step 1, note down before cleaning details in the logbook and also in log sheet for cleaning permeate flow, permeate TDS and conductivity, differential pressures for each stage, feed TDS and conductivity, etc. Step 2, fill the CIP tank with the permeate water from any unit to 10 to 20% and clean/flush and drain the cleaning tank. Filling through the permeate line before NaOCl dosing point. To remove any foreign particles inside the tank. Step 3, check the condition of the cartridge filters for cleaning and replace if necessary. Check the cleaning pump condition also. Open and check the cartridge filter condition. Step 4, fill the CIP tank with the permeate water from any unit to 100%. And check the chlorine concentration of water inside the cleaning tank. And make sure that it is 0. And flush both stages with permeate water. Make sure that the permeate water is not having any chlorine concentration at any time. Step 5, shut down the plant to be cleaned. Connect the cleaning pipelines as per shown in the diagram, inlet of the plant with CIP pump discharge and outlet of the plant return back to the CIP tank. Check the reject water TDS while flushing to ensure that all the saline water inside the units are flushed out. Step 6, fill the cleaning tank with permeate water from other running plant as per your installed membranes. Check the chlorine and add 1% of EDTA. Start the mixer inside the cleaning tank for proper mixing. Step 7. Circulate the water within the cleaning tank with cleaning pump to enhance the mixing and raise the cleaning solution temperature to 35 degrees Celsius. Check the pH of the solution. Should be approximately 12 or less. Adjust with 0.1% NaOH solution. Step 8. Route the valves in a way that the cleaning solution will enter the membranes and return to the CIP tank. Step 9. Start the cleaning pump with low flow 5 to 7 cubic meters per hour and drain the initial water from reject to drain. After initial water drain, arrange the valves and pipe to recirculation mode. To dispense the water inside the vessels and pipes. Step 10. Start circulation for 1 hour and maintain the flow and pressure as per above calculations. Step 11. Stop circulation after 1 hour and stop and put the membranes under soaking for 1 hour. Close all valves. Check the pH of the solution. Should be approximately 12. Adjust with 0.1% NaOH solution. Step 12. Open all valves and start circulation again after 1 hour. Step 13. Stop circulation after 1 hour and stop and put the membranes under soaking for ½ hour. Close all valves. Check the color of the cleaning solution inside the cleaning tank. If more dirty or dark, we need to change the cleaning solution. Step 14. Open all valves and start circulation again after ½ an hour. Step 15. After 1 hour, drain the cleaning solution to through. Dump valve at reject. Step 16. Fill the cleaning tank with permeate from the other plant to 20% and flush the cleaning tank, and then again fill the cleaning tank to 100% and flush the RO. Membranes for both stages. Check for the reject side pH to be same as that of the cleaning tank water pH. Step 17. Note down after cleaning details in the logbook and also in log sheet for cleaning. Before starting, refit the pipes and valves as before for normal operation. Citric acid or low pH cleaning procedure. Preparation of a 2% citric acid solution. Fill cleaning tank with water. Cleaning tank should be filled with RO permeate or softened water, free of oxidizing agents. The amount of cleaning water is determined by the size of the RO system and the extent of fouling. Dissolve citric acid. Add citric acid, white powder, in small increments to the cleaning water to obtain a 2% by weight of solution. Continuous agitation, or recirculation of the cleaning solution directly from the cleaning pump into the cleaning tank, will help to dissolve the citric acid quickly and completely. Break up any large chunks or lumps of citric acid prior to adding to the tank to avoid damaging the agitator or circulation pump parts. Example: to prepare 1000 liters of 2% by weight solution, 20 kilograms of citric acid are required. The solution pH should be adjusted with either ammonia, NH3, or sodium hydroxide, NaOH, to the specified value. Adjusting the pH of the solution with ammonium hydroxide should be performed with the agitator or recirculation pump in operation. Use an exhaust system if necessary to draw off released ammonia gas. Use of an electric drum transfer pump or manual drum transfer pump helps to minimize the release of ammonia gas. The amount of ammonium hydroxide, NH4OH, required to adjust the pH to 3.5 can be calculated approximately in proportion to the amount of citric acid by following formula. Amount of NH4OH, 100%, equals 0.1 x amount of citric acid, 100%, in kg.